The LEGO Mindstorms series of kits contains software and hardware to create customizable, programmable robots. They include an intelligent brick computer that controls the system, a set of the modular sensors and motors, and LEGO parts from the Technic line to create the mechanical systems. The hardware and software roots of the Mindstorms Robotics Invention System kit go back to the programmable brick created at the MIT Media Lab. This brick was programmed in Brick Logo. The first visual programming environment was called LEGOsheets, since it was created by the University of Colorado in 1994 based on AgentSheets. The original Mindstorms Robotics Invention System kit contained 2 motors, 2 touch sensors, and 1 light sensor. The Nxt version has 3 servo motors and 1 light, sound, and distance as well as 1 touch sensor. The Nxt 2.0 has 2 touch sensors as well as a light and distance sensor, and support for 4 without using a sensor multiplexer. LEGO Mindstorms may be used to build a model of an embedded system with computer-controlled electromechanical parts. Many kinds of real-life embedded systems, from elevator controllers to industrial robots, may be modeled using Mindstorms. Mindstorms kits are also sold and used as an educational tool, originally through a partnership between LEGO and the MIT Media Laboratory. The educational version of the products is called LEGO Mindstorms for Schools, and comes with the Robolab GUI-based programming software, developed at Tufts University using the National Instruments Lab View as an engine. In addition, the shipped software can be replaced with third-party firmware and/or programming languages, including some of the most popular ones used by professionals in the embedded systems industry, like Java and C. The only difference between the educational series, known as the Challenge Set, and the consumer series, known as the Inventor Set, is that it includes another touch sensor and several more gearing options. Mindstorms is named after the book Mindstorms, Children, Computers, and Powerful Ideas by Seymour Papert. The latest system, called the Lego Mindstorms Ev3, was released on September 1, 2013. Robotics Invention System =RCX=. The first generation of LEGO Mindstorms was built around a brick known as the RCX. It contains an 8-bit Renesas H8/300 microcontroller as its internal CPU. It included 32K of RAM to store the firmware and user programs. The brick is programmed by uploading a program from a Windows or Mac computer to the brick's RAM via a special infrared interface. After the user starts a program, an RCX-enabled Mindstorms creation can function totally on its own, acting on internal and external stimuli according to the programmed instructions. Also, 2 or several more RCX bricks can communicate with each other through the IR interface, enabling inter-brick cooperation or competition. In addition to the IR port, the system includes 3 sensor input ports and 3 motor output ports. An integral LCD can display the battery level, the status of the input-output ports, which program is selected or running, and other information. Version 1.0 RCX bricks feature a power adapter jack to allow continuous operation instead of the limited operation time when using batteries. In version 2.0, the power adapter jack was removed. Power adapter-equipped RCX bricks are popular for stationary robotics projects or for controlling LEGO model trains. In the latter context, the RCX needs to be programmed with digital command control software to operate multiple wired trains. The IR interface on the RCX is able to communicate with Spybots, Scout bricks, LEGO Train, and the Nxt. The RCX 1.0 IR receiver carrier frequency is 38.5 kHz, while the RCX 2.0 IR carrier frequency is 76 kHz. Both versions can transmit on either frequency. The carrier signal is generated by one of the RCX's internal timers. The RCX communicates with a computer using a serial or USB IR tower. The tower is supported by Windows 98, ME, and XP. A patch is available for hyper-threading multi-core CPUs. There is no formal support for Windows Vista, but there are reports of correct functionality. The USB tower does not work on a 64-bit OS unless a 32-bit OS is used in conjunction with a virtual machine. The serial tower works normally under 64-bit Windows 7 using a third-party USB to serial adapter. All versions of the RCX have a unique number printed on it, necessary for technical support and used as the ID number of the RCX for your LEGO Mindstorms account on the now-defunct LEGO Mindstorms RCX website. The first RCX produced is marked 000001, and was on display at the Mindstorms 10th anniversary event. Programming languages LEGO Mindstorms programming is command box programming, rather than code programming. LEGO supplied languages, RCX code, Robolab, popular third-party languages, NatGPL, allows programming Nxt using the Ada language for real-time and embedded programming. LEGOS, a port of Java, not exactly C, an open-source C-like high-level programming language, not quite C, RoboMind simple educational scripting language for virtual and LEGO Nxt robots. ROBOTC, C-based programming language with an easy-to-use development environment. Simulink, graphical signal processing and control design tool from which C code is auto-generated and deployed onto the Nxt. PB4, extensions to 4th, PBLUA, version of Lua, Visual Basic, via the COM Plus interface supplied on the CD. LEGO Camera, the LEGO camera on its own is technically not a robotic toy. Rather, it is a normal webcam packaged into a LEGO shell. Being a normal webcam, the LEGO camera is, unlike most Mindstorms products, not programmable and is only usable connected to a PC or some other device that supports USB webcams. The LEGO camera is meant to be used with the included Vision Commands software, which can also interface with an RCX and thus enables creating robots with vision. The software is capable of detecting different lightings, motion, and colors. It can also be used with any other software that uses a webcam. The webcam is capable of recording up to 30 frames per second. It also contains a microphone to record sound for videos. 4.5 Vpc Interface, the first programmable LEGO product. It came with a dedicated IBM PC-compatible ISA interface card, a ribbon cable, and a control panel. The control panel included 6 non-reversible 4.5V output ports, 3 reversible 4.5V output ports, 2 4.5V input ports, and 1 continuous 4.5V output port. It also features a manual override stop button. Using programs running on the host computer, the user could create stationary programmable robotic LEGO inventions using the older 4.5V system. The 4.5 Vpc interface was superseded by the 9V-based Dacta Control Lab in 1995. Technic Control Center, the Control Center was the first programmable standalone LEGO product, in the sense of being able to store sequence-based programs and run them. It featured 3 output ports and manual control, and it was only capable of storing linear sequences of manual input plus timing information. It could store up to 2 programs at once. The manual controls could be used to independently control the 3 motors. To record a program, the controller had to be put in programming mode, and then any manual control would be recorded to the program. Pauses could also be included in a program. When the recording was done, the controller could successfully recall and execute any manual action done during the recording. The executing program could be set to loop infinitely. Compared to the later programmable controllers, the Technic Control Center is extremely simple and can only barely be called programmable. Dacta Control Lab, released in 1995, the Dacta Control Lab was the first LEGO product to feature the sensors used in later 9V-based automated LEGO products. The Control Lab was a data logger, which featured 4 passive input ports, 4 active input ports, 8 controllable 9V output ports, and 1 continuous output port. It also featured a manual override stop button. The control panel connected to a computer using a serial port with a specially designed adapter cable, and a supplied computer program allowed the user to conditionally program the outputs. This allowed for robotic operation of mostly stationary LEGO inventions. The Control Lab superseded the old 4.5 Vpc interface from 1989, which was the first fully programmable LEGO interface. The connectors of the early sensors were color-coded according to their type. Active sensors had blue connectors and passive sensors had yellow connectors. Later bricks kept the color coding for the input ports, but the later sensors dropped the color coding of the connectors. The early touch sensors were also of a different kind and shape compared to the later touch sensors. Most notably, instead of featuring a removable cable, the cable was fixed just like the other sensors. These early sensors also featured longer cables. The Control Lab was designed for schools and educational use and was as a result not available to the mass market. It was later replaced by the RCX in the educational release of the Robot Invention System, which allowed for mobile inventions in addition to stationary inventions. Cybermaster. Cybermaster was mainly sold in Europe and Australia, New Zealand, and was available for a short time in the United States via the LEGO Club magazines. It was aimed at an older audience as an early attempt of merging with robotics and LEGO. The brick shares many, especially software, features with the RCX but differs in appearance and technical specifications, 1 output and 4 sensors. It uses RF instead of IR for communication. It has 2 built-in motors with integrated tachometers and speedometers. It is limited to passive sensors. The sensors shipped with it are color-coded and have internal resistors in their open state. It has a fixed firmware. It has unlimited RAM for programs and only 1 program slot. Despite its obvious limitations, it has a number of advantages over its big brother, the RCX. The RF link has greater range and is omnidirectional. The built-in tachometer and speedometer sensors on the internal motors provides the same function as the external rotation sensor to the RCX, but without using up sensor ports. This makes it very useful for various mobile platforms and performing advanced motion positioning tasks. It talks the same protocol as the RCX but cannot communicate directly to it, but with a repeater they can communicate indirectly. Codepilot, sold as part of the barcode truck kit. This unit was the first programmable brick. It features a single motor, a single touch sensor and a light sensor. It is programmed by setting it to learn and using the light sensor to feed barcoded commands. The command set is very limited. Since barcode is just a series of variances in light, this form of command entry was dubbed VLL and has been used in several later LEGO models. Scout. LEGO also released a blue computer called the Scout, which has 2 sensor ports, 2 motor ports, and a built-in light sensor, but no PC interface. It comes with the Robotics Discovery set. The Scout can be programmed from a collection of built-in program combinations. In order to program the Scout, a user must enable power mode on it. The Scout can store 1 program. The Scout is based on a Toshiba microcontroller with 32 kilobytes of ROM and 1 kilobyte of RAM, where about 400 bytes are available for user programs. Due to the extremely limited amount of RAM, many predefined subroutines were provided in ROM. The Scout only supports passive external sensors, which means that only touch, temperature and other unpowered sensors can be used. The analog-to-digital converters used in the Scout only have a resolution of 8 bits in contrast to the 10-bit converters of the RCX. There was a plan for LEGO to create a booster set that allows you to program the Scout from a computer with a software such as RCX code. However, due to the complexity of this project, it was abandoned. The RCX can control the Scout brick using the Send IR message program block. The RCX does all of the controlling, and therefore can be programmed with the PC, while the Scout accepts commands. The Scout brick must have all of its options set to off. Micro Scout. The Micro Scout was added as an entry level to LEGO Robotics. It is a very limited PBRICK with a single built-in light sensor and a single built-in motor. It has 7 built-in programs and can be controlled by a Scout, Spybotics or RCX unit using VLL. Like the Scout, the Micro Scout is also based on a microcontroller from Toshiba. The unit was sold as part of the Droid Developer Kit and later the Darkside Developer Kit. Spybotics. Spybotics is a robotics package. It consists of 4 color-coded robots called Spybots, a programming language with which to control the Spybots, and 10 simulated missions. Programming language. LEGO Mindstorms programming is command box programming, rather than code programming. LEGO supplied languages, Nxt code, Robolab. In order to use Robolab there are 2 steps involved. Step 1, purchase LVEE. This is the National Instruments Lab view for LEGO Mindstorms, item number 2257 from online LEGO education site. Step 2, install Robolab 2.9 Plus plugin, free download from the online LEGO Engineering Tufts U. If you have already owned the Robolab, you just need to download it from www.legoengineering.com. Popular third-party languages. There are many third-party programming languages out there. However, the following includes the most common ones: Robotcc-based programming language with an easy-to-use development environment. Microsoft Robotics, from Microsoft Developers Studio. You need to download the plugins online. LEGO Mindstorms Nxt. LEGO Mindstorms Nxt is a programmable robotics kit released by LEGO in July 2006, replacing the first-generation LEGO Mindstorms kit. The kit consists of 577 pieces, including 3 servo motors, 4 sensors, 7 connection cables, a USB interface cable, and the Nxt Intelligent Brick. The Intelligent Brick is the brain of a Mindstorms machine. It lets the robot autonomously perform different operations. The kit also includes NXTG, a graphical programming environment that enables the creation and downloading of programs to the NXT. The software also has instructions for 4 robots: AlphaX, Tribot, RoboArm T56, and Spike. LEGO Mindstorms Nxt Educational Version. This is the educational version of the Nxt set from LEGO Education, which is made for school use. Software is sold separately, and the Education resource set for the best use. It includes a light sensor, an ultrasonic sensor, a sound sensor, 3 lamps and a pair of touch sensors. The first set consists of about 400 pieces, and the extra set consists of about 600 pieces. The Education version is most suited for those who have older versions of Mindstorms sets around, mostly thanks to its 3 converter cables. It costs about $410 with the Bluetooth dongle. LEGO Mindstorms Nxt 2.0. The LEGO Mindstorms Nxt 2.0 was launched on August 5, 2009. It contains 619 pieces, 2 touch sensors, an ultrasonic sensor, and introduced a new color sensor. The Nxt 2.0 uses floating point operations whereas earlier versions use integer operation. The kit costs around $280. LEGO Mindstorms Ev3. The LEGO Mindstorms Ev3 is the 3rd generation LEGO Mindstorms product. LEGO announced the 3rd generation Mindstorms platform called Ev3. Ev3 is a further development of the Nxt. The system was released on September 1, 2013. The LEGO Mindstorms Ev3 set includes motors, sensors, the Ev3 programmable brick, 550 plus LEGO Technic elements and a remote control. The Ev3 can be controlled by smart devices. Programming languages. Community. There is a strong community of professionals and hobbyists of all ages involved in the sharing of designs, programming techniques, creating third-party software and hardware, and contributing of other ideas associated with LEGO Mindstorms. The LEGO Mindstorms system website is organized much like a wiki, harnessing the creative potential and collaborative efforts of participants. LEGO also encourages sharing and peering by making software code available for downloading and by holding various contests and events. See also: First LEGO League, WRO, First Tech Challenge, RoboCup Junior Big Track, iRobot Create, RobFest, Robotispoloid, The Robotic Workshop, LEGO Logo, an earlier use of LEGO bricks with computer control. Robotics Suite. Notes. References, Bagnall, Brian. Maximum Lego Nxt, Building Robots with Java Brains Variant Press. 2007. ISBN 0-9738649-1-5, Bagnall, Brian. Core Lego Mindstorms Prentice Hall Ptr. 2002. ISBN 0-13-009364-5, Baum, Dave. Definitive Guide to Lego Mindstorms, 2nd ed. A Press. 2002. ISBN 1-59059-063-5. Owen, Benjamin. Creative Projects with Lego Mindstorms. Addison Wesley. 2001. ISBN 0-201-70895-7. Ferrari al. Building Robots with Lego Mindstorms, the Ultimate Tool for Mindstorms Maniacs. Singress. 2001. ISBN 1-928,994-67-9. Gindling, J., A. Ioniador, J. Lowe, O. Lockabo, and A. Repenning, LEGOsheets, a rule-based programming, simulation and manipulation environment for the Lego programmable brick, proceeding of visual languages, Darmstadt, Germany, IEEE Computer Society Press, 1995, pages 172-179. Bria plus or minus immoral, Juan Antonio. Develop LEGOS program step by step, http, www.juanantonio.info. External links, Official Lego Mindstorms.